Hello there. My name is Alara, and welcome to the Late Night Science Channel. Tonight we're going somewhere special, somewhere vast, somewhere ancient, somewhere that's been your home since before you even existed. We're going to explore the Milky Way galaxy, but not in the way you might expect. No. Tonight, you get to simply rest. Close your eyes, let your breathing slow, and drift with me through the cosmic river of stars that wraps around us all. So, before we begin, just settle in. Find that comfortable position, the one where your body feels like it's sinking into the mattress, where gravity feels just a little softer. You don't need to do anything but listen. And if you find these gentle journeys through science help you unwind at the end of your day, consider subscribing to the channel. It helps other sleepy souls find their way here too, one peaceful night at a time. Now, let's begin. The Milky Way, our home galaxy, is so much more than just a pretty streak of light across a dark sky. It's a massive, slowly turning spiral that's been rotating through space for over 13 billion years. That's older than almost anything else we know. Older than our sun, older than Earth, older than the mountains and oceans and every living thing that's ever walked or swam or flown. And yet, beneath all that ancient beauty, there are secrets, strange, wonderful secrets about rogue stars, invisible matter, collisions that happened before humans even existed, and mysteries we're only just beginning to understand. Tonight, you'll hear about things that might surprise you, or at the very least, spark a little curiosity as you drift towards sleep. Things about black holes hiding in the dark, stellar nurseries where baby stars are born, and the odd, unfinished story of a galaxy that's still growing, still changing, still consuming smaller galaxies even now. You know, the Milky Way hasn't always been alone. It's collided with other galaxies before, absorbed them, pulled them apart like unraveling a sweater, thread by thread. And it's going to happen again. Right now, at this very moment, a smaller galaxy called the Sagittarius dwarf is being torn apart by our galaxy's gravity. Its stars are being stretched into long, thin streams that wrap around the Milky Way like ribbons. And far away, much farther than you can see with your eyes, the Andromeda galaxy is drifting closer. In about 4.5 billion years, give or take, the Milky Way and Andromeda will collide. Now, don't worry, this won't be some catastrophic explosion. Stars are so far apart from each other that they'll almost never actually hit. But the shapes of both galaxies, they'll change forever. They'll fold into each other, stretch and pull, and eventually merge into something new. Something vast and quiet and different. Even galaxies, you see, aren't eternal. They evolve, they collide, they begin again. And here's something that might make you pause for a second. Some of the stars in the Milky Way, they're older than the Milky Way itself. How is that possible, you might wonder? Well, not every star you see was born here. Some stars, especially the really ancient ones, wandering in long, tilted orbits high above the galaxy's main disk, they seem to have formed before the Milky Way even fully took shape. Astronomers believe these stars might have come from smaller, primordial galaxies, little pockets of stars that merged with ours billions of years ago. You can tell how old they are by their chemical fingerprints. These stars have almost no heavy elements in them, just hydrogen and helium, the simplest ingredients, which suggest they were born shortly after the Big Bang. They move slowly, drifting high above the flat plane where most stars live, like elder spirits from a time before spirals, before order, before structure. In their dim light, we glimpse a universe that was younger, wilder, still learning how to become what it is now. And speaking of motion, did you know our entire solar system is racing through the galaxy right now? Not just Earth spinning, not just Earth orbiting the sun, but the whole solar system, sun and planets and all, moving at over 828,000 kilometers per hour. That's more than 230 kilometers every single second. And even at that incredible speed, it still takes about 225 million years to complete just one loop around the galaxy. Think about that for a moment. One orbit, one galactic year, takes 225 Earth years. Since the solar system formed, we've only gone around the Milky Way about 20 times. When the first dinosaurs appeared, we were in a completely different part of the galaxy. The stars you see outside your window tonight, they weren't always nearby, and they won't always be there. Everything is in motion, quietly, slowly, endlessly. Even as you lie here, even as you close your eyes and feel yourself sinking deeper into rest, the Earth is turning, the moon is circling, and the entire solar system is sweeping forward through a galaxy that never stops moving. The galaxy is still growing, even now. Though it's ancient, it isn't finished. It continues to gather material from the space around it, pulling in gas from the intergalactic medium, capturing stars from dwarf galaxies that wandered too close, drawing in streams of dark matter that feed its massive halo. It grows not like a living thing grows, but like a gravitational structure deepening over time, layer by layer, collision by collision. Some of this growth happens quietly, just clouds of gas slowly filling in gaps. Other times it's more dramatic. Satellite galaxies are torn apart, their stars scattered across the sky in long glowing trails. The galaxy you live in today is not the same one the dinosaurs saw when they looked up at the night sky, and the one your distant descendants might know, assuming humanity lasts that long. It could be even larger, stitched together from the ruins of 1,000 smaller worlds. Now, here's something we still don't fully understand. We don't actually know how many spiral arms the Milky Way has. You'd think that would be one of the basic things we'd know about our own galaxy, right? But from our position, deep inside the disk, it's really hard to see the whole structure. Dust clouds block our view of distant regions. Stars blur together. For decades, astronomers thought there were 4 major spiral arms. Then, more recent observations suggested maybe fewer, or that the arms twist and split in ways more complex than we expected. Some arms fade into fragments, others wrap around in unexpected ways. The Milky Way might not be a neat, symmetrical pinwheel at all. It might be more like a living, layered swirl of stars, shaped by forces we still don't fully understand, constantly shifting, constantly reshaping itself. And then there are the rogue stars. Most stars drift calmly through the galaxy, following predictable orbits. But a rare few are flung outward at astonishing speeds, fast enough actually to escape the Milky Way entirely. These are called hypervelocity stars. Some of them are remnants of binary star systems, two stars orbiting each other that got too close to the supermassive black hole at the center of the galaxy. What happens is one star falls into the black hole and vanishes. The other star gets slingshot outward, hurled into the darkness at over 1,000,000 kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no return ticket. They remind us that even in a galaxy bound together by gravity, there are moments of violent release, quiet expulsions that send stars flying into the intergalactic night, never to come back. Let's talk about that collision with Andromeda again for just a moment, because it's one of those things that sounds dramatic, but is actually kind of beautiful when you think about it. High above the horizon, if you know where to look and you're far from city lights, the Andromeda galaxy appears as a faint, fuzzy blur to the naked eye. It's a spiral galaxy, much like our own, lying over 2 million light-years away. And yet, it's moving steadily towards us. In about 4.5 billion years, the Milky Way and Andromeda will collide. But it won't be violent in the way you might imagine, not like cars crashing or planets smashing together. No, stars are spaced too far apart for that. Instead, their gravity will warp both galaxies into long, stretching arcs. Tidal tails will curl outward like ribbons. The supermassive black holes at the centers of both galaxies might spiral together, eventually merging into one even larger black hole. And after billions of years, the two galaxies will fully merge into a single, larger system. Astronomers have already given this future galaxy a name. They call it Milkomeda, a blend of Milky Way and Andromeda. It'll be a slow, elegant dance, the future of our home written across the stars. Now, most stars in the Milky Way orbit the galactic center in the same general direction, all moving together like cars on a highway. But not all of them follow the rules. Some stars, especially in the outer halo, move in retrograde. They orbit opposite to the galaxy's main rotation. These stars likely arrived from elsewhere, born in dwarf galaxies that were later absorbed by the Milky Way. Their reversed motion is like a quiet signature of their foreign origin. It's as if the galaxy carries old memories in its motion, stories of ancient mergers and cosmic encounters, preserved not in light, but in the slow, patient turning of stars against the stream. Over billions of years, the Milky Way hasn't grown alone. It has consumed. Small galaxies, faint companions, have drifted too close, been caught in its gravity, and slowly dismantled. Their stars are now part of our halo, part of our disk, woven into the stellar streams that wrap around the galaxy. Astronomers have identified several of these mergers by analyzing how stars move and what they're made of. One especially large event, called the Gaia-Enceladus merger, added a huge number of stars to the Milky Way and may have reshaped the early structure of the galaxy. The Milky Way isn't a pristine spiral that formed all at once. It's a composite, built from quiet collisions, stitched together from the remains of many smaller worlds. Every star carries a unique chemical fingerprint, a pattern of elements that was imprinted at birth. By studying these signatures, astronomers can trace where a star came from, when it was born, what kind of environment it formed in. Some stars are rich in heavy elements like iron and calcium, which suggests they formed in dense, metal-rich regions where previous generations of stars had already lived and died. Others are nearly pure hydrogen and helium, born when the universe was still young and hadn't yet created many heavier elements. These differences allow scientists to group stars into families, uncover ancient mergers, and reconstruct the hidden story of how the Milky Way formed. In this way, chemistry becomes a kind of time machine, letting us read a star's past like a line of ancient poetry written in light. Across the sky, thin ribbons of stars stretch in arcs and curves, barely visible, but unmistakable when mapped with precision. These are stellar streams, the remnants of smaller galaxies that wandered too close to the Milky Way and were pulled apart. As they orbit, their stars get smeared across space by tidal forces, forming long, delicate trails that trace their former paths. Some wrap around the galaxy like ghostly halos. Others dive inward toward the core. These streams are evidence of past collisions, quiet mergers that built the Milky Way over billions of years. The galaxy, like a tree, carries the rings of its past in every thread of light.
You know, our galaxy doesn't even lie flat. The Milky Way's disk bends upward on one side and downward on the other, forming this graceful wave across the stars. This subtle warp was invisible to us until radio telescopes mapped the hydrogen gas that stretches far beyond the starlight. Astronomers believe the distortion might be caused by satellite galaxies tugging gently on the Milky Way's edges, or by clumps of dark matter bending the structure from below. Like ripples in a great spinning sheet, the warp reveals that even galaxies are never fully still. Over time, they bend, they flex, they change form in response to invisible forces. From a distance, the Milky Way might look like it's dancing slowly through space. Here's something that might put things in perspective. Under a clear, dark sky, far from cities and streetlights, you might see a few thousand stars with your naked eye. To the human eye, that seems like an ocean of light, but it's barely a droplet. The Milky Way contains over 100 billion stars. Most are hidden from view. Some lie behind thick curtains of dust. Others are too faint, too far away for our vision to reach. That pale streak of light you see crossing the sky on moonless nights, that's just the innermost whisper of the whole galaxy. We live surrounded by this colossal river of starlight, and yet almost all of it remains invisible to us too vast to grasp from within. And here's another interesting thing. Unlike planets in a solar system, which follow neat, predictable tracks around their star, stars in the Milky Way move with more freedom. Some race ahead in the inner regions. Others drift slowly along the outskirts. This difference in speed is actually why spiral arms form in the first place. They're not solid structures, not like the arms of a starfish. They're patterns, like slow-moving traffic jams of stars and gas moving through space. As these density waves pass through a region, they compress the gas and trigger new stars to form, lighting up the arms in blues and whites. Our own sun is part of this swirl, moving in and out of these patterns across time. The galaxy isn't a clock, it's a current, and we're drifting in it. The galaxy holds together because of something we can't see. By all logic, based on what we can actually measure, the stars and dust and gas, the outer edges of the galaxy are spinning too fast. They should be flung into space, scattered like leaves in a storm. And yet they remain, held in place. The answer is dark matter. This mysterious substance doesn't shine, doesn't reflect light, doesn't emit any light, but it exerts gravity, and there's so much of it that it outweighs all the visible matter in the galaxy many times over. We don't know what dark matter is. We can't see it, can't touch it, can't detect it directly. But we know that without it, the Milky Way would fly apart. It's the invisible scaffolding that holds everything in place. At the very center of the Milky Way lies an enormous black hole, a singular point of gravity called Sagittarius A star. It's more than 4 million times the mass of the Sun, yet it occupies a space smaller than the orbit of Mercury. We can't see it directly, of course, but we've watched nearby stars whip around it at tremendous speeds, tracing invisible loops through the void. Sometimes gas and dust fall inward and flare with X-rays as they spiral towards the event horizon. For now, Sagittarius A star is relatively quiet, sleeping. But long ago, it may have burned like a quasar, lighting up the galaxy from within, a brilliant, violent beacon. It's the silent conductor at the Milky Way's heart, pulling stars into a slow, relentless dance. When astronomers mapped the center of the galaxy in detail, they discovered something unexpected. The central bulge, that thick concentration of stars at the core, isn't a smooth, round ball. It's shaped more like a peanut. Seen from the side, it swells in the middle and narrows at the ends, like a twisting hourglass made of stars. This strange geometry likely formed from the galaxy's central bar, a dense stripe of stars that rotates slowly through the core, buckling and puffing upward over time. These inner structures are sculpted by gravity, by billions of years of motion, by the accumulated rhythm of stellar orbits. We live in a spiral galaxy, but its heart is full of complexity, not flat or clean, but intricate and alive. The Milky Way's spiral arms aren't simply made of stars. They're woven from the birthplaces of stars. Giant clouds of hydrogen, dust, and molecules drift through the galaxy, and when these clouds pass through the spiral arms, they're compressed, squeezed, and that compression sets them alight with newborn suns. These regions are called stellar nurseries. They're chaotic, glowing, full of motion. Ultraviolet light from new stars lights up the clouds, painting the arms with radiant blues and silvers. These bursts of creation trace out the spiral shape, illuminating the curves of the galaxy with quiet fire. Every star, even our sun, was born from one of these cloudy cradles long ago. Beyond the flat spiral disk lies something far more diffuse, a spherical halo that surrounds the entire galaxy. It contains ancient stars, globular clusters, and enormous amounts of dark matter. Though it's nearly invisible, this halo may actually hold majority of the Milky Way's mass. Its stars are spread thin across vast distances, orbiting in long, slow arcs that rarely touch the disk. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. It's the galaxy's outer memory, quiet and dim, but still in motion, still shaping what the Milky Way becomes. Scattered throughout the halo, orbiting the galactic center like moths circling a distant flame, are more than 150 globular clusters. These are among the oldest objects in the galaxy. They're compact spheres made of hundreds of thousands of tightly bound stars, packed so closely together that if you lived on a planet inside one, the night sky would be filled with thousands of brilliant stars, far brighter than anything we see from Earth. These clusters are incredibly stable. Some are more than 12 billion years old, and many contain stars that actually predate the Milky Way itself. Their stars are what astronomers call metal poor, meaning they formed before the universe had time to create many heavier elements. They serve as time capsules, holding clues to how the galaxy formed, what it consumed, and what conditions were like in the early cosmos. These quiet, golden spheres drift patiently above and below the galactic plane, glowing softly in the dark. Long ago, the Milky Way was more active, bursting with fresh stars born from dense, collapsing clouds. But in recent epochs, the pace has slowed. There's still gas available, but much of it is spread thin, heated, or locked in forms that resist collapse. The galaxy isn't done making stars, but it's settling down. Astronomers estimate that star formation peaked billions of years ago and has been declining ever since. This doesn't mean the end is near, only that we live in a quieter chapter of the galaxy's story, a mature spiral, glowing gently in its middle age, still forming stars, but no longer in a hurry. The disk, that broad, flat spiral we think of as the Milky Way, formed gradually over time. But some of the stars in our galaxy are older than the disk itself. These ancient stars reside mostly in the halo, or in what's called the thick disk, and they formed when the galaxy was still assembling, just a loose cloud of stars, gas and dark matter, slowly collapsing inward. By studying their composition and motion, astronomers can peer back into the era before structure, before spirals, before order. These stars are the elders of the galaxy, silent witnesses to its birth and the long, slow shaping of what we now call home. As the sun orbits the center of the Milky Way, it completes one full revolution every few 100 million years. This is called a galactic year, a vast cycle of motion that dwarfs all our calendars, all our recorded history. In the time it takes for the sun to circle the galaxy once, continents drift, mountain ranges rise and erode, species rise and fall, entire epochs unfold. It's thought that we're currently about halfway through one such orbit. The last time the solar system was in this part of its path, the supercontinent Pangaea had just begun to break apart, and dinosaurs hadn't yet emerged. A galactic year is the slow heartbeat of cosmic time. In all of its 4.6 billion years of existence, the sun has only circled the Milky Way around 20 times. That's fewer than you might expect, considering its incredible speed, nearly 830,000 kilometers per hour. But the galaxy is so vast, the sun's path so long, that each orbit takes hundreds of millions of years. We often think of stars as ancient and unmoving, but our solar system is still young on a galactic scale, a newcomer in a city of older, more traveled suns. We're part of the galaxy's motion, but still early in its long, winding story. Here's something strange that puzzled scientists for a long time. According to Newtonian physics, stars farther from the galactic center should orbit more slowly, just like outer planets move more leisurely around the sun. But in the Milky Way, stars in the outer regions orbit almost as quickly as those near the center. This defies classical expectations. The reason, astronomers believe, is dark matter again. that invisible, unknown form of mass that surrounds the galaxy in a vast halo. Without dark matter, the galaxy wouldn't hold together. With it, the math works. The Milky Way turns almost like a solid wheel, not because we understand it fully, but because something unseen is holding it in place. Scattered throughout the Milky Way are vast, dark clouds of cold gas, the raw material of future stars. These molecular clouds, composed mostly of hydrogen molecules and traces of dust, can span hundreds of light years across. Within their cold, dense interiors, gravity begins to gather material, forming clumps that eventually collapse into new stars and planets. Some of these clouds are so large and so cold that they absorb visible light entirely, appearing as black patches against the starry sky. They're the galaxy's wombs, quiet, hidden places where the future begins in silence, tucked within curtains of shadow and gas. When massive stars reach the end of their lives, they explode in cataclysmic supernovae. Events so powerful, they can briefly outshine entire galaxies. These explosions don't just end lives, though. They create. Shock waves from supernovae ripple through the interstellar medium, compressing nearby clouds and triggering new waves of star formation. They enrich the surrounding space with heavy elements like iron, gold, and uranium, forged in the heart of the dying star. In this way, supernovae act like storms within the galactic ecosystem, stirring, fertilizing, reshaping everything around them. They're the galaxy's moments of chaos, destructive and radiant, and absolutely necessary for the cycle of creation to continue. The Milky Way is full of light we cannot see. Interstellar dust made of microscopic grains of carbon, silicon, and ice weaves through the galaxy in clouds and tendrils. Invisible light, it obscures vast regions of space, blotting out stars and entire nebulae. But behind this veil, star formation continues in secret. Infrared telescopes can peer through the dust, revealing glittering nurseries filled with newborn suns. What looks like darkness is often a cradle. The dust, though it hides things from view, is actually part of the process. It absorbs energy, helps gas cool, and shields the delicate early stages of stellar birth. What seems like emptiness is often the beginning of something bright. Not every cloud of gas becomes a star. Across the Milky Way, astronomers have found massive cold clouds that seem destined to collapse, yet remain dark and dormant. Some are too diffuse. Others may be stabilized by magnetic fields or internal turbulence. These starless clouds float through the galaxy like silent possibilities, rich in molecular hydrogen but untouched by fusion. They may one day ignite, or they may drift until torn apart by external forces, recycled into other regions. In these clouds, the galaxy holds its breath, waiting, perhaps for the right nudge to spark something new. Stars aren't permanent. They live, they burn, and they die. And in dying, they return their material to the galaxy. Supernovae spread heavy elements across space. Red giants shed their outer layers in beautiful planetary nebulae. This enriched material joins the interstellar medium, where it cools, condenses, and eventually forms new stars, new planets, and yes, even new life. Every atom in your body has passed through this cycle. Born in a star, scattered into space, gathered into new forms. The Milky Way isn't a static stage. It's a great engine of renewal. It breathes in time with its stars, making and unmaking and beginning again, over and over for billions of years. In astronomy, the word metals doesn't just mean iron or gold. It refers to any elements heavier than helium. The earliest stars in the universe had almost none of these metals because they formed before earlier generations of stars had a chance to forge and scatter them. Today, astronomers seek out metal-poor stars in the halo of the Milky Way. These stars, faint and ancient, preserve the chemical conditions of a time long gone, a period just after the Big Bang, before galaxies had matured, before the galaxy itself had taken full shape. They're fossils made of light, carrying information from a universe that no longer exists in that form. A star's birthplace doesn't always define its destiny. Over time, many stars drift away from where they were born, pushed by gravitational interactions, orbital resonance, or the slow pull of spiral arms. Some stars are ejected at high speeds, flung across the disk or into the halo. Others migrate gradually, shifting their orbits inward or outward as they spiral through the galaxy. Even our sun isn't where it began. Tracing the paths of stars reveals a Milky Way that's anything but static, a galaxy alive with movement, exchange, and quiet dislocation. Home for a star may only be temporary. Just as Earth orbits in what scientists call the habitable zone around the sun, not too hot or too cold for liquid water to exist, the Milky Way may have its own galactic habitable zone. This region is thought to lie somewhere between the dangerous inner core, full of radiation and gravitational chaos, and the sparse, metal-poor outer edges, where planets may be harder to form. Somewhere in between lies a wide band where conditions are stable, star density is moderate, and elements like carbon, oxygen, and iron are abundant enough to build rocky planets. Earth lies within this zone, one quiet orbit in a vast swirl where life might not be alone in finding a foothold. The Milky Way's spiral arms might seem like permanent features, grand sweeping lines carved into the galaxy's disk, but they're not made of fixed stars. Instead, they're patterns, density waves that ripple slowly through the disk, compressing gas and triggering new stars as they pass. Stars drift into these arms, shine brightly for a while, and then drift out again. The spiral structure moves at a different speed than the stars themselves, like a traffic jam moving slowly down a highway. From afar, it looks like form and order. From within, it's a pattern of shifting motion, held together by gravity and time, never still, always flowing. Beyond visible light, the galaxy glows with more mysterious forms of energy. Cosmic rays, high-energy particles born in supernovae and distant galaxies, stream through space and pass through your body every second. X-rays and gamma rays shimmer from dying stars and black holes. Radio waves drift from gas clouds, pulsars, and the cold breath of hydrogen. These invisible signals reveal what light cannot show us: the violence,
the magnetism, and the ancient fires still flickering within the galaxy's bones. When you look into the night sky, you're only seeing a narrow band of the Milky Way's true spectrum. Beneath the stars, the galaxy hums softly in many colors, many frequencies, a hidden symphony in the dark. Stretching tens of thousands of light years above and below the galactic center are two vast ghostly lobes of high-energy light called the Fermi bubbles. They were discovered only recently, and they glow in gamma rays, extending like twin balloons from the Milky Way's heart. No one is entirely sure what caused them. They may be the remnants of a long-ago outburst from the central black hole, or the mark of fierce star formation that once flared through the core. Either way, these enormous structures drift silently over the galaxy, invisible to human eyes, but detectable by specialized instruments. They're reminders that the Milky Way has a past we cannot fully see, echoes of violence wrapped in radiance far above the stars we know. Our solar system doesn't lie in one of the Milky Way's grand spiral arms. Instead, we occupy a small structure called the Orion Spur, a relatively quiet lane of stars nestled between the larger Sagittarius and Perseus arms. It's not especially dense, not especially active, but that may actually be why we're here. In this calm space between galactic highways, massive supernovae are rarer. Radiation storms are less frequent. This quiet corner may have given life on Earth the time it needed to emerge and evolve, to develop complexity without being sterilized by nearby cosmic violence. From the outside, the galaxy seems dramatic and radiant, but in this quiet spur, we found just enough peace for life to unfold. When astronomers look toward the galactic core in infrared light, they don't see a perfect circle. They see a thick, elongated bar of stars crossing the middle, a kind of glowing bridge. This bar rotates slowly, and its gravitational pull shapes the inner spiral arms. Bars like this are common in spiral galaxies. They form when stars in the disk begin to drift inward and pile up along a central axis. Over time, the bar becomes a stable structure, stirring gas, triggering new stars, and feeding material toward the black hole at the center. It's not just a shape, it's a dynamic engine, sculpting the galaxy's heart from within. The Milky Way doesn't exist in isolation. It belongs to a collection of more than 50 galaxies known as the Local Group, a small cluster drifting together through space. The two largest members are the Milky Way and Andromeda, each with its own family of satellite galaxies. Scattered around them are smaller dwarfs, faint ellipticals, and star-poor galaxies made almost entirely of dark matter. The local group spans 10 million light years, and it's bound together not by proximity alone, but by gravity. We're part of a family, quiet, widely spaced, but still linked by the invisible threads of shared motion and mutual pull. Despite their vast separations, the galaxies of the local group aren't drifting apart. In fact, many are moving slowly toward one another. Gravity holds them in a kind of slow-motion ballet, curving their paths across millions of years.
Some of the smallest galaxies orbit the Milky Way like moons, looping and falling, dissolving into streams over time. Others drift independently, but remain tethered, caught in a web of shared motion. Over time, this group may condense further. Galaxies may merge, fade, or be absorbed. It's not a static arrangement. It's a gentle gathering of cosmic islands, a family drawn closer by time, inertia, and the long reach of gravity. The Milky Way's disk looks flat from a distance, but up close, it's layered. There's the thin disk, where we live, a wide, dense plain filled with young stars, open clusters, and star-forming gas. But above and below it lies the thick disk, older, puffier, more diffuse. Stars in the thick disk tend to be older with fewer heavy elements. They move in orbits that are more tilted and elliptical, suggesting they formed under different conditions or were stirred by early galactic collisions. The galaxy's disk isn't uniform. It's textured, layered, shaped by time, like sediment settled on the floor of a cosmic ocean. Though invisible to the eye, the Milky Way is laced with a vast magnetic field, stretching across the disk, rising into the halo, weaving through the interstellar medium. This field is weak by earthly standards, but over galactic distances, it shapes how cosmic rays travel, how gas clouds collapse, how matter flows through space. It aligns with spiral arms, forms arcs above the plane, twists into loops that defy simple explanation. Studying it requires radio telescopes and careful analysis, but its presence is unmistakable. The Milky Way doesn't just glow with light, it breathes with magnetism, a subtle pulse running through its bones. Between the stars lies more than emptiness. The interstellar medium, a thin blend of gas, dust, and plasma, weaves its way through the Milky Way like fog. To the naked eye, it's mostly invisible, but when viewed with radio and infrared telescopes, it reveals stunning complexity. It forms filaments, bubbles, shock waves, cold, dense clouds where stars are born. Supernovae carve vast cavities in it. Stellar winds sculpt it into shapes that ripple across light years. The space between stars isn't a void. It's a shifting web of matter and magnetism, the quiet fabric from which galaxies evolve and life eventually begins. Every second, high-energy particles, mostly protons and atomic nuclei, stream through your body. They were launched long ago by exploding stars. These are cosmic rays, and they're everywhere, traveling close to the speed of light, bending through magnetic fields, bouncing off clouds, occasionally colliding with atoms in Earth's atmosphere, where they create showers of secondary particles. Most of the time, we don't notice them, but they carry stories from across the galaxy, evidence of ancient supernovae, traces of distant acceleration, messages from the violent hearts of stars. Even as you rest here, even as you drift toward sleep, the galaxy is whispering in particles, in silence, in lightless rays passing through you. Though many diagrams show the Milky Way as a neat, even spiral, it's not perfectly balanced. One side of the disk appears thicker. Some spiral arms are brighter, longer, or more curved than others. The warp in the outer disk is lopsided. Even the star counts between hemispheres are slightly off. These asymmetries may be caused by gravitational encounters, past mergers, or the influence of dark matter. They remind us that galaxies, like living things, carry traces of their histories in their shapes, scars of collisions, wrinkles of time, quirks of uneven growth that give them character and depth. High above the galactic plane, drifting through the halo, astronomers discovered a star that may be as old as the universe itself.
It contains almost no heavy elements, a signature of stars born soon after the Big Bang, before generations of supernovae enriched the cosmos. It likely formed over 13 billion years ago, long before the Milky Way was fully formed. It burns quietly now with a soft red glow, low in mass, but rich in history. It's not just a star, it's a time capsule, a living relic from the universe's earliest dawn, still shining faintly in the dark. In the inner regions of the Milky Way, stars orbit the center much more rapidly than those farther out. Near the core, the gravitational pull is stronger, packed with mass from stars, dust, and the supermassive black hole Sagittarius A star. This causes stars to sweep through tighter, faster orbits, completing revolutions in just a few million years. Out in the suburbs of the galaxy, like where our sun lives, stars orbit slowly, taking hundreds of millions of years. This uneven rotation creates twisting patterns, stretches spiral arms, and keeps the disk from behaving like a solid structure. The galaxy moves like a great wheel, but one whose rim lags behind its core. In the dark arms of the Milky Way, star formation begins in silence. Massive clouds of molecular hydrogen, sometimes hundreds of light years wide, drift through space, chilled to just a few degrees above absolute zero. Within these clouds, gravity slowly takes hold. Small regions grow denser and begin to collapse under their own weight. As the gas falls inward, it heats up, spins, and flattens, forming a protostar at the center. Over time, the pressure and temperature grow until nuclear fusion ignites, and a new star is born. From the coldest shadows come the brightest lights, spun gently into being by the quiet force of gravity. Many stars are born not in isolation, but in groups. Tight clusters formed from the same collapsing gas cloud. These clusters, bound by mutual gravity, drift together for millions or even billions of years. But over time, they begin to scatter. Tidal furfurs from the Milky Way's mass, close encounters with other stars, internal dynamics, all work to pull clusters apart, and stars peel away one by one until the cluster fades into the general star field of the galaxy. Even our sun was likely born in a stellar cluster long ago. Its siblings are now scattered, dimmed, or lost in the haze of distance. In the rarest and most precious objects in the Milky Way are hyper-metal-poor stars. Stars whose atmospheres contain almost no elements heavier than helium. Some contain less than 1/10,000th the iron found in the sun. These stars are believed to be among the first born after the very first supernovae, carrying only faint traces of enrichment from a universe still forming itself. They're incredibly old, incredibly pure, scattered in the halo like distant lanterns from the dawn of time. Each one is a kind of relic, a glowing, gravitationally bound signature from a near-forgotten epoch. Planets aren't a rare feature of the cosmos. They were a natural consequence of star formation. As a new star ignites, a rotating disk of leftover gas and dust surrounds it. Within this disk, particles stick together, gather mass, and grow into worlds. Across the Milky Way, planetary systems are common. Some are vast, with gas giants and frozen moons. Others are compact, with rocky planets hugging close to dim stars. Some may resemble our own solar system, while others defy our expectations entirely. The galaxy isn't just full of stars, it's full of systems, solar families, each one with its own unique balance, orbit, and potential. In the Milky Way, the spiral arms rotate at a different speed than individual stars, like a moving pattern rather than a solid structure. But there's a special distance from the center, called the co-rotation radius, where the average speed of stars matches the rotation speed of the spiral arms themselves. Earth's sun orbits close to this boundary. This gentle match in motion may help us avoid frequent crossings of spiral arms, places with higher star density, more supernovae, and gravitational disturbances. We live, quite possibly, in a more stable neighborhood of the galaxy, shielded not by walls, but by resonance, by timing, by quiet luck. As it orbits the Milky Way, the sun doesn't follow a perfectly flat path. Instead, it moves in a gentle wave, drifting above and below the galactic plane like a cork bobbing in slow motion, rising and falling over tens of millions of years. This vertical oscillation is caused by the gravitational tug of the galaxy's mass, pulling and releasing the solar system as it moves. Some researchers have even wondered whether this motion might influence cycles of extinction on Earth, though the evidence isn't yet clear. Still, it's a reminder that even on its steady path around the center, the sun isn't gliding smoothly. It's swaying softly through space. Dark matter makes up most of the Milky Way's mass, yet it's never been seen directly. It doesn't emit or absorb light. It passes through ordinary matter as if it weren't there. But its gravitational effects are unmistakable. It holds the galaxy together, explains the unexpected rotation speeds of stars, shapes the formation of large-scale cosmic structures. Without it, the Milky Way would fly apart. Astronomers detect it not by seeing it, but by watching how it moves other things, how it bends light, how it affects motion. It's the galaxy's hidden scaffolding, invisible, silent, and still one of the greatest mysteries in science. Most of the Milky Way's visible stars lie within the flat, luminous disk, but the majority of its mass resides elsewhere. The galaxy is surrounded by an enormous dark matter halo extending far beyond the farthest stars. This halo holds the galaxy together, outweighing the disk by a large margin. It's populated sparsely with ancient stars and globular clusters, but its true bulk is unseen. When we think of the Milky Way, we picture its spiral arms and starry plane, but that's only the glowing surface. The mass that defines the galaxy, its gravity, its motion, its reach, is mostly hidden, enveloping everything like a quiet shroud. Today, the heart of our galaxy appears quiet, but there's evidence that it once was dramatically more active. The presence of huge gamma-ray structures like the Fermi bubbles and traces of high-energy light reflected in surrounding clouds suggests that the supermassive black hole at the center may have once flared as a quasar. Quasars are among the brightest objects in the universe, outshining entire galaxies, fueled by infalling matter spiraling into a black hole. If the Milky Way once burned like this, it would have looked dramatically different, a spiral wrapped around a blinding heart of light. That time has passed, but the echoes remain, written in radiation and mystery. Galaxies may look timeless, but they're always evolving. Spiral arms shift, bars form and dissolve, gas flows inward and outward, stars are born and die, leaving behind a changing population. Even the shape of the Milky Way's disk, warped, rippling, lopsided, is slowly altering. Encounters with dwarf galaxies and dark matter can bend or twist the structure. Over billions of years, the galaxy's silhouette has shifted like a drifting cloud. The Milky Way of today is not the one that was and not the one that will be. Its beauty lies not in permanence, but in quiet transformation. All across the universe, massive objects collide. Black holes spiral together, neutron stars crash, entire galaxies merge. These events send out gravitational waves, ripples in the fabric of space-time itself. Though faint, some of these waves pass through the Milky Way, distorting space by tiny amounts as they travel. They're incredibly difficult to detect, but observatories like LIGO and Virgo have already captured several. New experiments aim to detect the background hum of gravitational waves that fill the cosmos. Even now, as you rest, space itself is shifting. Not enough to feel, but enough to tell us that somewhere far away, the universe is changing. Not all stars move in nice circles around the galactic center. Some follow long, stretched ellipses. Their paths loop high above and far below the disk, tilted at odd angles from the main plane. These stars likely come from different origins, relics of dwarf galaxies swallowed by the Milky Way, or survivors of ancient gravitational upheavals. Their orbits are clues, three-dimensional maps of the galaxy's cosmic past. These stars drift like messengers from disrupted systems, tilted, stretched, but still bound to the whole. Every second, trillions of neutrinos pass through your body, straight from the stars. These ghostly particles are produced in nuclear reactions, from the sun, from supernova, from cosmic rays striking atoms in space. The Milky Way is bathed in them.
Yet they're so light, so unreactive, that they slip through almost everything, leaving no trace. Special observatories, buried deep underground or under ice, try to catch just a few flashes of light from a rare collision. Neutrinos carry information from places we cannot see, from stellar cores, from collapsing giants, from the galaxy's unseen energy. They're the whispers of cosmic fire, passing through us constantly, unnoticed. Between the stars, space isn't smooth or still. The interstellar medium, thin clouds of gas and dust, is stirred by shock waves, magnetic fields, the motion of stars. Temperature can vary wildly. Flows of material collide, mix, fragment. Clouds stretch, fold, tumble. On large scales, this creates a kind of turbulence, like a slow-motion ocean swirling through the disk. Star formation, cosmic rays, even galactic evolution are all affected by this restless sea. What looks from afar like calm starlight is, up close, a dynamic, rippling fabric shaped by invisible winds and ancient energy. Planets aren't always tethered to stars. Some form normally and are later ejected from their systems. Others may never have had a star at all. These are rogue planets, worlds adrift in the galaxy, cold, dark, and alone. Though difficult to detect, studies suggest there may be billions of them in the Milky Way, some even in the outer halo, where stars are few and far between. Without light or warmth, they float unseen, warmed only by internal heat. They're orphans of the galaxy, planetary drifters, following long, lonely paths through the darkness between stars. Interstellar dust,
tiny grains of carbon and silicon, moves not just under gravity, but also under the influence of the galaxy's magnetic field. These fields thread through the Milky Way like invisible currents, guiding the motion of charged particles and influencing how gas and dust align. In some regions, dust grains spin rapidly, emitting faint microwave light. In others, they align with magnetic lines, polarizing the starlight that passes through them. Understanding these effects helps astronomers trace the magnetic field structure and even remove its influence from cosmic background studies. Dust isn't passive. It dances to a magnetic rhythm, falling into hidden patterns in the dark. When two neutron stars spiral together and collide, they create one of the most violent events in the universe, a kilonova. In this brief, blinding explosion, enormous quantities of heavy elements are forged: gold, platinum, uranium, and more. These materials are cast into space, mixing with gas and eventually forming new stars. Some stars in the Milky Way carry the chemical fingerprints of these rare events, enriched in elements that could only have come from such collisions. They're not just luminous bodies, they're record keepers of ancient cataclysms, burning with the residue of stellar wreckage and cosmic alchemy. At the heart of the galaxy lies a bar of stars, an elongated bridge of light crossing the central bulge. But deep within that bar, astronomers have found hints of another, smaller bar, tilted at a different angle, rotating independently. This inner structure is difficult to see directly, obscured by dust and distance, but its gravitational influence appears in the motion of nearby stars and gas. Bars like this may help funnel material toward the supermassive black hole, feeding it and shaping the dynamics of the core. The Milky Way's center isn't one simple shape. It's a layered, shifting labyrinth of light and motion. The Milky Way isn't a closed system. It draws in fresh gas from the intergalactic medium, long, tenuous streams flowing through the vast cosmic web. These inflows provide the raw material for new stars, replenishing what the galaxy loses over time. Some gas arrives as cold filaments, slipping quietly into the disk. Other streams fall in hotter, shock-heated forms, lighting up in ultraviolet or X-ray light. These invisible rivers sustain the galaxy's growth and evolution, linking it to the larger universe beyond. Even now, the Milky Way drinks from distant reservoirs, nourished by threads of matter spun from the early cosmos. When massive stars die and collapse into neutron stars, they may be left spinning fast and precise, with beams of radiation sweeping across space. These are pulsars, and some rotate hundreds of times per second, pulsing in regular, measurable rhythms. They're so consistent that astronomers use them as cosmic timekeepers, tracking their signals to measure distances, test gravity, even search for gravitational waves. Across the Milky Way, pulsars blink quietly, remnants of death, but also beacons of astonishing order. They keep time not for minutes or days, but for entire epochs, ticking steadily in the silence between stars. Much of the Milky Way is invisible light, hidden by dust, distance, or faintness. But radio waves can slip through these barriers, revealing structures otherwise unseen. They trace cold hydrogen gas, outline magnetic fields, highlight emissions from pulsars, supernova remnants, even distant quasars beyond the galaxy. Using arrays of radio telescopes, astronomers have mapped the spiral arms, measured the warp of the disk, discovered star-forming regions cloaked in darkness. Where light is blocked, radio soundings let us see. The galaxy speaks in a language we can't hear, but one that science has learned to translate into shape and shadow. Stars rarely form in solitude. They're usually born in groups, stellar clusters shaped from the same collapsing cloud of gas and dust. Our sun was almost certainly one of these. Long ago, it shared space with hundreds, perhaps thousands of sibling stars, all born in the same cradle. Over time, gravitational tides, passing stars, the motion of the galaxy, scattered the cluster. Most of the sun's siblings have wandered far, flung into different orbits, carrying with them fragments of our shared past. Some may still shine nearby, invisible among the stars, lost family in a sea of light. Though the sun's birth cluster has long since dissolved, astronomers are searching for its lost siblings, stars that share its age, motion, and chemical fingerprint. Using vast surveys like Gaia and spectroscopic databases, researchers hope to identify these long-lost relatives. A few candidates have emerged, stars that may have shared our origin, formed from the same cloud of enriched gas. If found, they could reveal details about the conditions in which the sun and the early solar system were born. Our place in the galaxy isn't entirely solitary. Somewhere out there, the sun's ancient kin may still shine. The Milky Way's disk isn't perfectly flat. It wobbles gently, rippling like a spinning plate nudged off balance. This warp is most visible in the outer regions, where the disk bends upward on one side and downward on the other. It may be caused by the gravitational influence of nearby dwarf galaxies, interactions with dark matter, or internal asymmetries. The wobble rotates slowly, like a vast wave moving through the stars. From Earth, we don't feel it, but from afar, the Milky Way isn't a pristine spiral. It's a breathing, undulating sheet of stars, curving gently as it turns. Just as the moon's gravity pulls tides on Earth, the immense mass of the Milky Way exerts tidal forces on everything within it. Star clusters, satellite galaxies, even globular groups feel the galaxy's uneven gravitational pull. Over time, these tides can stretch and distort them, drawing out long stellar streams or peeling stars away from their orbits. Many of the faint arcs of stars mapped across the sky are remnants of such encounters. Clusters in the process of being unraveled, galaxies slowly torn apart. The galaxy doesn't break these structures suddenly. It unravels them patiently, strand by strand, over millions of years. You might think we'd know the mass of our own galaxy, but measuring it is remarkably difficult. Stars and gas make up only a small portion of the total mass. The rest lies in the vast dark matter halo, which we can't see directly. Estimates vary. Some suggest a mass close to 1 trillion times that of the sun. Others place it much higher. The uncertainty comes from trying to measure how fast stars orbit at great distances, a task clouded by limited data and the influence of invisible matter. The Milky Way is our home, but its weight remains a quiet mystery. For many years, astronomers assumed that the Andromeda galaxy, slightly larger and brighter than the Milky Way, was also more massive. But recent measurements suggest that the Milky Way's dark matter halo may be broader and denser than previously believed. If that's true, our galaxy could actually outweigh Andromeda, despite its more modest appearance. This matters not only for comparisons, but for predictions. When the two galaxies eventually merge, their relative masses will shape the encounter's dynamics. The Milky Way may look gentle, but beneath its quiet spiral arms, it carries more weight than we once imagined. The Large and Small Magellanic Clouds, two bright satellite galaxies visible from the southern hemisphere, have long been thought to orbit the Milky Way, but new evidence suggests they may be newcomers, captured only recently in cosmic terms. Their velocity and motion through space hint that this could be their first close pass. If true, they're not long-standing companions, but distant wanderers just now falling under the Milky Way's pull. Their arrival has stirred the outer disk and warped the galaxy's shape, like the Milky Way is responding to a new gravitational guest. The sky is full of first encounters, quiet and slow. Trailing behind the Magellanic Clouds is a vast ribbon of hydrogen gas, a structure called the Magellanic Stream. It stretches over hundreds of thousands of light years, wrapped in curves and arcs across the southern sky. This stream was pulled away by tidal forces as the dwarf galaxies passed close to one another and to the Milky Way. Invisible in light, it reveals itself in radio wavelengths, a long trailing whisper of motion and loss. The stream may one day feed new star formation in the Milky Way, or settle into the halo like a thread of memory stretching between galaxies. Not everything in the Milky Way follows the neat plane of the disk. Some clouds of gas, and even some stars, move in highly inclined orbits, passing above and below the galaxy's main structure. These polar orbits likely come from past mergers, when dwarf galaxies or stray clouds were captured at odd angles. Over time, they continue to orbit on tilted paths, like comets around a planet. These misaligned orbits are records of disruption, visible reminders that the galaxy isn't a closed system, but an evolving structure shaped by the unpredictable flow of cosmic history. In several regions of the Milky Way, astronomers have found enormous spherical shells of gas, some spanning hundreds of light years. These shells are the remnants of powerful starbursts, episodes when clusters of massive stars formed together, lived brief lives, and exploded in rapid succession. Their combined winds and supernovae carved out huge cavities in the interstellar medium, blowing gas outward in all directions. Over time, the expansion slows, but the shells remain, ghostly bubbles marking where the galaxy once burned bright with stellar birth and death. These are the fossils of cosmic fireworks, still echoing in the cold. Space is vast and stars are small, but in the densest regions of the Milky Way, such as the cores of globular clusters, stars can pass close enough to interact and even collide. When they do, the result can be dramatic: a burst of light, the merging of two suns, or the formation of a rare blue straggler star, one that appears younger than its neighbors. These collisions are rare, but not impossible. Over billions of years, the tightest stellar neighborhoods can rearrange themselves through gravity and chance. In these crowded stellar cities, time moves differently, and space is never quite empty. Most stars live in pairs, orbiting each other in gravitational embrace. But even this bond can be broken. If a binary system passes close to the Milky Way's central black hole or through a dense cluster, tidal forces can disrupt their orbit, flinging one star away while the other is captured or slowed. In some cases, a companion is hurled out of the galaxy entirely, becoming a rogue star speeding through intergalactic space. These stellar breakups happen silently in places we rarely see, a quiet tearing of ancient partnerships by gravity's indifferent hand. Most stars are gravitationally bound to the Milky Way, but occasionally a star reaches escape velocity, over 500 kilometers per second, and is flung outward, never to return. These hypervelocity stars are rare but real. Some are thought to be ejected by interactions with the supermassive black hole at the galaxy's center. Others may be slingshot by three-body encounters or supernovae in binary systems. Once free, they travel alone into intergalactic space, tiny lighthouses drifting far beyond the spiral's edge. They carry the galaxy's memory outward, becoming solitary pilgrims in the great dark between galaxies. Not all stars within the Milky Way were born here. Some may have originated in other galaxies, captured during mergers or flung into our halo from distant regions of the local group. These intergalactic wanderers often move on unusual orbits, far from the disk, tracing paths through the outskirts or halo. They can be identified by their composition or motion, stars that don't quite fit the local patterns. Like cosmic immigrants, they bring stories from other environments, other histories, other skies. The Milky Way isn't a sealed system. It's a living mosaic, slowly stitched together by time and motion. Above and below the Milky Way's bright disk, gas rises and falls in a quiet loop known as the galactic fountain. Supernovae and stellar winds heat and eject material upward into the halo, where it cools, condenses, and gently rains back down over millions of years. This cycle stirs the interstellar medium, redistributes heavy elements, helps regulate star formation. It's a quiet respiration, a breathing motion of matter between the dense plane and the vast halo. The galaxy, in this way, doesn't just spin, it circulates. It exhales and inhales, keeping its structure in motion across immense spans of time. Within the clouds of interstellar dust that drift between stars, scientists have detected complex organic molecules, carbon-based compounds that form the raw ingredients for life. These include polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more. Though not alive, they're chemically rich, formed in the atmospheres of dying stars or within cold clouds shaped by radiation. These tiny grains, carried across light years by galactic winds, settle into the gas that forms stars and planets. Some may have fallen onto the early Earth. The galaxy's dust isn't just debris, it's cargo. A cargo of potential drifting silently through the dark. The birthplaces of stars are also the birthplaces of worlds. As planetary systems form from collapsing clouds of gas and dust, they inherit the chemical fingerprints of their parent nebula. If that cloud contains water, carbon compounds, other building blocks of biology, those ingredients may end up in comets, asteroids, or planets. Some regions of the Milky Way are especially rich in such prebiotic chemistry. We don't yet know how common life is, but the conditions for it seem to arise naturally. The seeds of life may be scattered far and wide, tucked into the galaxy's coldest cradles, waiting for a place to grow. Most stars spin, but some spin incredibly fast, completing a full rotation in just a few hours. These rapid rotators are often young, massive, unstable, with equators that bulge from centrifugal force. A few reach such high speeds that they fling off material, forming glowing disks around themselves. The sun rotates once every 25 to 35 days, depending on latitude. But these fast-spinning stars rotate hundreds of times more quickly, approaching physical limits. Their internal structures and evolutionary paths are different. Their lives may be brief, but while they last, they spin like sirens in the dark. From Earth, the Milky Way arcs across the night sky in a graceful band of light, but it doesn't align with the plane of our solar system. The galactic plane, the flat disk in which most of the galaxy's stars reside, is tilted about 60 degrees relative to the ecliptic, the path traced by the sun and planets. This tilt is why the Milky Way rises at an angle, why it shifts position with the seasons. We're part of the galaxy, but our own little system is angled slightly askew, a small tilted boat drifting through a larger, spinning sea of stars. Among the faint stars in the halo, astronomers have found white dwarfs, the cooling cores of once luminous stars that are older than the Milky Way's thin disk itself. These ancient remnants formed when the galaxy was young, before its main structure had fully settled. They've burned for billions of years, slowly fading, carrying with them the quiet residue of a time when the Milky Way was still gathering its shape. The disk may be bright, but the halo remembers further back. The Milky Way's most distant stars orbit far beyond the familiar spiral arms, tens or even hundreds of thousands of light years from the center. These stars move through the galactic halo on slow, wide paths, taking billions of years to complete a single orbit. Many were likely captured from smaller galaxies in past mergers, now drifting in the outermost reaches like distant sentinels. They're faint, sparse, far between, but they help define the galaxy's size, shape, and gravitational influence. The Milky Way isn't just what we see, it extends deep into the dark, shaped by wanderers at its edge. Though often pictured as a symmetric spiral, the Milky Way is subtly lopsided. One side of the disk is thicker than the other. The spiral arms are uneven in brightness and extent. Even the stellar halo is slightly off-center. These asymmetries likely arise from gravitational interactions with the Magellanic Clouds, with dark matter clumps, with past mergers. The galaxy isn't a perfect pinwheel. It's a living structure marked by tugs and twists, like a spinning dancer whose skirt has been caught by the wind. Its beauty lies in that irregularity, a graceful imbalance sculpted by time. Certain stars pulse in brightness over regular intervals, expanding and contracting like slow, luminous heartbeats.
These are variable stars, and some types, like Cepheids and RR Lyrae stars, have well-known relationships between their brightness and their pulse period. By measuring how long a star takes to brighten and dim, astronomers can determine its true luminosity, and by comparing that to how bright it appears, its distance. These stars serve as cosmic yardsticks, helping us map the shape, structure, and scale of the Milky Way. They're lights that measure the dark, blinking beacons scattered through the spiral. Launched by the European Space Agency, the Gaia spacecraft is creating the most precise map of the Milky Way ever made. By measuring the positions, motions, and brightness of over 2 billion stars, Gaia reveals the galaxy's three-dimensional structure and its motion through time. It's uncovered streams from shredded galaxies, mapped the warp of the disk, traced the sun's orbit with exquisite detail. With each new data release, Gaia deepens our understanding, turning a hazy smear of stars into a sharp, living map. It's astronomy's most ambitious star chart, a quiet revolution unfolding among the stars. If you look up on a dark night away from city lights, you may see a hazy river of starlight crossing the sky. That's the galactic plane, the thickest slice of the Milky Way's disk. It's not a line, but a depth, a vast flattened band where the majority of the galaxy's stars reside. Through this band, stars are densely packed. Dust is layered. Star formation is common. From our vantage point, we're looking along the grain of the galaxy, peering through its richest corridors. This band isn't just beautiful, it's the crowded, humming heart of where most stars live and die. The core of the Milky Way lies in the direction of the constellation Sagittarius, a rich, glowing concentration of stars, dust, and unseen mass. From Earth, we can't see the very center in visible light. Dust clouds obscure our view, but the area glows with brightness in infrared and radio. Even with the naked eye, the region appears more crowded, more luminous, filled with the overlapping light of billions of stars. We orbit far from the center, in a quiet suburb of the galactic disk. But when we look inward, we glimpse the crowded city at the heart of the galaxy. Because we live within it, we cannot look down on the Milky Way from above. Instead, we see it from the inside, a flat ribbon of stars stretching across the sky, curved only by the horizon. This edge-on view compresses the galaxy into a single arc, making it hard to grasp its full structure from our perspective. It took centuries of observation, cataloging, mathematical deduction to realize the spiral we belong to. From Earth, we gaze through its disk, like standing in a forest and looking along the line of the trees. We don't see the shape we're part of, only the vastness that surrounds us. Even with our most sensitive instruments, we glimpse only a fraction of what the Milky Way contains. Light is blocked by dust. Motion is hidden in silence. Dark matter outnumbers luminous stars. Between every star lies emptiness, and within every empty space, potential. The Milky Way isn't just what we see, it's what we suspect, what we infer, what we long to understand. It holds ancient light, future stars, drifting worlds, questions still without answers. And within that vastness, somehow, we find ourselves. One planet among many, orbiting a quiet star, floating through a story too wide for the eye to hold. And now the stars begin to dim behind your thoughts. We've drifted through so many quiet truths tonight, from the warp of the galaxy's disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow and everything in between. You've wandered through stellar nurseries, danced along spiral arms, gazed toward the galactic heart glowing behind curtains of dust. You're a part of this galaxy, you know, not just a passenger on Earth, but a participant in its long and luminous unfolding. The iron in your blood was forged in stars. The oxygen you breathe was sculpted in ancient explosions. The atoms of your body trace their lineage to the earliest times, born from the same matter that now fuels suns and whispers through clouds of interstellar dust. Tonight, as you rest, the galaxy turns on. Stars are forming, light is traveling, silent orbits continue, and you're floating within it, a small warmth in the dark, resting in the spiral arm of a quiet, radiant sea. If you enjoyed this peaceful journey through the stars, you might like exploring more mysteries of the universe with me. There's always another story waiting, another question drifting through the cosmic dark. I'll see you there, whenever you're ready. For now, though, just rest. Let the galaxy spin. Let your breathing slow and drift softly into sleep. Good night.